Hi, Algebra 1. We're going to be working on continuing with our quadratic equations here, but now we're writing them in both standard and factored form. Here we go. Let's skip ahead in this lesson to activity 2, and they're showing here how we've already used diagrams to show expressions like x times x plus 5, x times x plus 5, and how when we multiply this out, we'd end up with x squared plus 5x. Now we're looking at what happens if we have a negative. So x times x minus 5, right here, we can rewrite as x times x plus a negative 5. And so then we see, here's our x plus negative 5 times x. And we just do the same thing, just paying close attention to our negatives. Negative 5 times x is going to be negative 5x. And so our answer here would be that this is the same as x squared minus 5x. We want to show, using either a diagram or the distributive property, that x minus 1 times x minus 1 is the same thing as x squared minus 2x plus 1. I'm going to start with the diagram. Here I've set up my diagram. Here's my x minus 1, or it's the same thing as x plus negative 1, if you want to think about it that way, times x minus 1. And so my first box, I have x times x, which is x squared, negative 1 times x, which is negative 1x. Same thing here, negative 1 times x is negative 1x. And then right here, negative 1 times negative 1 is a positive 1. And I'm combining like terms. I have negative x and negative x. I can combine those. So I still have x squared, just one of those, minus 2x. That's combining my negative 1x here and negative 1x there. And then plus 1 at the end. I'm going to do the same thing using the distributive property. I'm first going to take my first x and multiply it by both terms in the other factor. So I have x times x, which is x squared, and then x times negative 1, which is going to be negative x. Now I'm going to take negative 1 and multiply it by both terms in the other factor. So negative 1 times x is going to be negative x, and negative 1 times negative 1 is going to be a positive 1. I'm going to simplify. I have those like terms. Negative x minus x is negative 2x plus 1. So we see that they are exactly the same. So you can use either method you like. You can use the diagram, which I think of as kind of being like Punnett squares back from life science, or you can use a distributive property. Either one is going to get you the same answer. For A, here's my diagram, x plus 1 times x minus 1, and this is what I ended up with, and I simplified. My x minus x is just going to get rid of those x's. There's 0 x's left, and so I'm left with x squared minus 1. I'm going to do the same thing using distributive property over here. X times x is x squared, x times negative 1 is negative x, and then I like to switch colors here. 1 times x is x, and 1 times negative 1 is negative 1. So I end up with x squared, negative x, and positive x, that just ends up being 0, minus 1. When you get to C and you're setting it up, it looks a little bit different. X minus 2 squared just means x minus 2 times itself. So this is what it would look like set up to do the distributive property. This is what it looks like set up in a diagram. Going on to our last activity, we have a set of quadratics that are written in standard form, and then we have some that are not written in standard form. Number 1 is asking about what are some characteristics of expressions in standard form. So some things that we should be noticing here is that there is a squared term. We see that squared, or that 2 as the exponent at some point in the expression. The order of the terms doesn't matter. You know, it's the same thing like 2 plus 3 is the same as 3 plus 2. But some textbooks will say that the squared term needs to come first, as it is in this one, in order for it to be in standard form. But in our book, they really don't care about that. The other thing you notice is that there's not always an x term, which what I mean by that is, like in this one right here, I have an x squared and I have a plain old number, but I don't have anything with just x like I do right here and right here. Over in these that are not written in standard form, there are some things we want to notice about these three. These are written in what we call factored form. The reason it's called factored form is because there's two factors being multiplied together. Down here it's x plus 8 times negative x plus 5. Here we have x plus 1 times x minus 1. And here we have 2x plus 3 times just x. Two pieces being multiplied together.